Okay, so in Pascal's triangle, it actually looks like a triangle of numbers. And to get any number in Pascal's triangle, you have to add the two numbers above it. So for example, for row 3, it would be 1 plus 0 is 1, 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 0 is 1. So we're going to take it all the way down to the end of the page. Row 4. 1 plus 0 is 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1 plus 0 is 1. And the beauty of it is there's so many patterns in it. It's quite a remarkable triangle. So row 5. Notice we started with row 0. The first one is called row 0. Then the second row is called row 1. Then 2. So let's do row 5. 1 plus 0 is 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. 1 plus 0 is 1. Row 6. 1 plus 0 is 1. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. That should be a 20. 10 plus 5 is 15. 6 plus 1 is 6. 1 plus 0 is 1. So row 7. So this is entry 0, this is entry 1. Notice that entry 1, that's considered 1, that's considered entry 0. So entry 1 always matches the row number. 5, 5, 4, 4, 3, 3, 2, 2, 1, 1, 0. Okay, so this is 1, 7, 21, 35, 35, 21, 7, 1. Row 8. 1, 8, 28, 56, 70. Yeah, 28, 8, 1. Row 9. 1, 9, 36, 84, and this is 84, 36, 9, 1. So we have done we've done 10 rows actually, but up to row 9 of Pascal's triangle. Yeah. Hallelujah. Okay, I want to point out some properties about Pascal. You still need the bottom part? Okay, hold it. I just have to bend this over, so there. Okay, so we're gonna write some properties on here. Okay, note. Note. Okay. 1. Each term is the sum of the terms immediately above it. Each term is the sum of the terms immediately above it. 2. The first and last term in each row is 1, right? 1, 1, 1, 1, 1, 1, 1, 1. So the first and last term in each row is 1. Each term is represented by T subscript N, comma, R. Don't put a comma on the end. There's just one comma in the subscript. So T N subscript R, okay, where N is the row number and R is the position number. Position number. T subscript N comma R is equal to the sum of the terms above it. So in the row above, so the row above is N minus 1 comma R plus T N minus 1 R minus 1. So this is T subscript NR equals T N minus 1R plus T N minus 1R minus 1. So for example, T6 comma 2, T6, the 0 entry, the first entry, the second entry, right, is equal to T5, yes, 2 plus T5, 2 minus 1 is 1. So for example, so T6, 2, 0, 1, 2, right? It starts at 0, is 15, is equal to T5, 2, 0, 1, 2, T5, 2, this is T5, 2, right? And this is T5, 1, is equal to 10 plus 5, right? 10 plus 5 is 15. So this is T5, 2 plus T5, 1 equals T6, 2. So for example, if we do T 9, 5, well, T9, 5 is 0, 1, 2, 3, 4, 5 is 1, 2, 6, right? That equals T8, 5 plus T8, 4. So notice 1, 2, 6 equals this term plus this term. T8, 5 is 0, 1, 2, 3, 4, 5. T8, 5 is 56. T8, 4 is 70. And they add up. That's how it works, okay? Notice, if I were to add up these terms, should I slow down? Well, that's 6, 16, 26, 31, 32. Do you notice that the sum of this is 32? The sum of this is 5, 16. The sum of this is 8. Do you see a pattern? The sum of this is 4. The sum of this is 2. The sum of that is 1. What would you think the pattern is? This equals 2 to the 5. This equals 2 to the 4. This equals 2 to the 3. Do you see a pattern? 2 to the 2, 2 to the 1, 2 to the 0, right? So the pattern is number 5. The sum of any row n equals 2 to the n. So the sum of row 7 so the sum of row 7 would equal 2 to the 7, right? And that equals 128. So you don't have to add them. You could, 29, you could go, but if you don't want to add them, you just go 2 to the n equals 128. Are we good? Are you, Alina, sorry, any questions? Does anybody need this? Do you want me to slow down? No? Yes? No? Okay, I'll wait. Can we put away our cell phones, please, and write notes? Okay, so Pascal's triangle is named after Pascal because he collected several results known about the triangle or different patterns, right? Then Newton used these patterns to develop the binomial theorem, which we'll learn on Thursday. So use Pascal's triangle. The sum of the terms, well, you know this already. I gave you a heads up. 2 to the 0 equals 1. 2 to the 1 equals 2. 2 to the 2 equals 4. 2 to the 3 equals 8. And 2 to the 4 equals 16. The sum of the terms in row n of Pascal's triangle is just 2 to the n. Use your answer to predict the sum of the terms in row 15. So what would I do? 2 to the 15 equals 32,768. So remember, we count the rows starting at row 0. Similarly, we'd count the terms starting at position 0. So it starts at 0, right? So find what's t comma 3 comma 1? Huh? T31 is equal to, so go to row 3, 0 is equal to 3, right? What's T55? What's T72? No, T71 is 7. What's T72? 21. 0, 1, 2. T72 is 21. What's T73? Now, there's a way to get this without Pascal's triangle, but I have to find I need my calculator. Hold it. Sorry, what was your question? Yeah, it's a squished in 3. Let me write that better. I want to show you something right now. Look for your NCR button on your calculator. Look for your NCR button. What happens when you go 3 NCR1? Watch. 3 NCR, oh, I have to turn it on. 3 NCR1, and I get 3. Right? 3, 5C5, if I go 5 NCR5, I get 1. If I go 7 NCR7, right? 7 choose 7. We'll talk a little bit. Oh, so that should be 7 choose 2, you should get 21. And if you go 7, choose 3, you should get 35. Without giving you, all I can tell you is that your C button, for now, all you need to know is your combinations button will give you any entry in Pascal's triangle. Yeah. So look for your NCR button. Some of you have it above the 5, right? I have it like this. I like this calculator. I use it for data. I need that NCR button. Yeah. So let's say I want T 15, 3. That is equal to 15, choose 3, and you can just sub it in. 15 NCR 3 equals 455. You do. If you bring it up here, I can show you. I just can't walk away from the mic. So go, I think it's in data. No. Probability. There, it's there. Okay, there. So you would go 15, probability, move it over, enter, 3. Okay. Are we good with the calculators? Okay, I'm continuing now. Excuse me. What is the term directly below T72 and T73? But I want it in TNR form. Yes. T83. Because T8, 3 equals T7, 3 plus T7, 2. Write an equation using these guys. T what equals what? Well, what do these add up to? T what? The row below. 9, 6 equals T8, 5 plus T8, 6. Sorry. Yeah. Okay. So the sum of the terms in the 8th row add up to the entry in the 9th row. So if it's T8, 5 and T8, 6, then the sum of those two is T9. Just remember the pattern, right? Can I answer any questions on this page? We have another page to do, and then we'll call it a day. Okay, combinatorial notation can be used to represent the terms in Pascal's triangle. Guys, can you take out your earphones? I'd be walking over there and grabbing your phones if it wasn't that I'm not attached to a microphone. Okay, so this is read as N choose R. It's a combinatorial thing. It has great meaning in metadata management and probability, okay? But for now, for grade 11 purposes, that's all you need to know. Each term in Pascal's triangle is equal to the sum of the two consecutive terms Is there an issue? In the row immediately above. Given by the recursion formula, we'll talk about recursion formulas a little later, Tn minus 1r plus Tn minus r comma r, oh, that should be n minus 1, r minus 1. So TNR equals the row above n minus 1, right? And then it's r and r minus 1. Using combinatorial notation, this is going to equal n minus 1 choose r plus n minus 1 choose r minus 1. This is known as Pascal's formula. Rewrite the following using Pascal's formula. That equals, anyone want to give it a try? What would this equal? Plus? No, it's still in the row above. 11, choose. In any entry, there's only two rows involved. The one you're talking about plus the one above. And what does this equal to? 20? 20 choose? Good. List the coefficients of each binomial expansion, then add the numbers in the diagonals. Ready? What's x plus y to the 0? Okay. So 1 will go there. Okay, what's x plus y to the 1? Notice that the coefficient for x is 1 and the coefficient for y is 1, right? So that 1 goes there. Now, x plus y squared, if I were to go x plus y times x plus y, I get x squared plus 2xy plus y. What are the coefficients? 1, 2, 1, right? Y squared, I'm sorry, thank you. I didn't know you were wondering, why are people yelling y squared? Okay, there, okay, now I know. Now if I go x squared plus 2xy plus y squared times x plus y, I would get, and I'm not going to multiply because I know the answer and you're going to learn this tomorrow. This would equal x cubed plus 3x squared y plus 3xy squared plus y cubed. And the coefficients are 1, 3, 3, 1. Do you see where we're getting the coefficients from? Where are these coming from? Where do you see these numbers happening? Yeah, and they're coming from what triangle? Right? 1, 3, 3, 1. 1, 4, 6, 4, 1. So if we go to the 4, we get 1, 4, 6, 4, 1. And if we go to row 5, because the exponent is 5, we get 1, 5, 10, 10, 5, 1. And here the exponent is 6, and our coefficients will be 1, 6, 15, 20, 15, 6, 1. These come from, the coefficients come from Pascal's triangle. Sorry? Like that? Yes, so let's add them now. 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 plus 1 is 5. 1 plus 4 plus 3 is 8. This is 6 plus 6, this is 13. This is called the Fibonacci sequence. Yes, it was discovered by an Italian person, Fibonacci. So the Fibonacci sequence is where any number equals the sum of the previous two numbers. So T N R equals T N R minus 1 plus T, no, wait a minute, my bad. Tn equals Tn minus 1 plus Tn minus 2. And n, I think, should be greater than or equal to 3. We're going to start with 3, okay? So 1, 2, 3. So the third term equals the sum of the first two terms, right? The third term equals the sum of the first term, and the fourth term equals this sum. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. So any term is the sum of the immediately two terms, the immediately preceding two terms. This is T1, T2, T3. Can I answer any questions? That's the Fibonacci sequence. Any questions? Does it seem like a lot? But it's easy stuff, though, once you learn it, right? I'm sorry. Normally, I would let you do this on your own, but for the sake of time, I just wanted to make sure you had it all.